Ever pondered the process of how machine learning algorithms interpret data? This fascinating process is built upon a series of mathematical principles and procedures. Within this intricate process, one element stands out for its fundamental role in evaluating the performance of these algorithms, the confusion matrix. So what exactly is a confusion matrix? It's a specific table layout that allows visualization of the performance of an algorithm. It's especially useful in supervised learning, where the outcomes are known ahead of time. Imagine a scenario where an algorithm is trained to identify cats and dogs. After the training phase, the algorithm is tested with new images. The confusion matrix comes into play here by systematically capturing the results of this test. It has 4 quadrants, each representing a different outcome. The first quadrant, true positives, represents the number of cats correctly identified as cats. The second quadrant, true negatives, represents the number of dogs correctly identified as dogs. The third quadrant, false positives, represents the number of dogs incorrectly identified as cats. And the last quadrant, false negatives, represents the number of cats incorrectly identified as dogs. Output: by quantifying these outcomes, the confusion matrix provides a clear and concise summary of what an algorithm got right and what it got wrong. It's a cornerstone in understanding and improving the performance of machine learning models. But it's not just about counting correct and incorrect predictions. The confusion matrix also helps calculate more complex metrics like precision, recall, and F1 score. Precision. Think of precision as asking, when the model says something is positive, how often is it correct? It focuses on the accuracy of positive predictions. If the model claims something is positive, precision tells you how likely it is to be right. Recall. Consider recall as asking, out of all the actual positive cases, how many did the model catch? It emphasizes not missing positive instances. Recall if there are positive cases. Recall tells you how well the model is at finding them. The F1 score is a measure of a test's accuracy, and it considers both the precision and the recall. To recap, a confusion matrix is a powerful tool in the world of machine learning. It provides a systematic way to visualize and understand the performance of an algorithm. It goes beyond simple correct and incorrect counts, offering deeper insights through metrics like precision, recall, and the F1 score. And that's a confusion matrix demystified in 2 minutes.